Okay, welcome back. So we said that we have certain conditions under which we could prove that two triangles were congruent without having to show that all of these 6 measurements were equal to the 6 measurements in the other triangle. One of the conditions is, if you have two triangles, you know that they're congruent if the 3 sides in one triangle are equal in measure to 3 sides in the other triangle. So for instance, and we have a little shorthand here actually, SSS stands for side, side, side. That's what we use when we're, I suppose, writing mathematically really. So if we have two triangles and we know that this side is equal to this side is equal to this side is equal to this side, then we don't need to find out that this angle is equal to this, and this angle is equal to this, and this angle is equal to this, to be able to say that they're congruent. Because mathematically, we know if the 3 sides are equal, the 3 angles have to be equal. So we don't have to go any further than saying that because of SSS, these two triangles are congruent. Okay. Another way of proving that two triangles are congruent is if two triangles have 2 sides and the included angle are equal. So two triangles are congruent if 2 sides and the included angle in one are equal to 2 sides and the included angle in the other. And we, for shorthand, we say SAS for side, angle, side. So if we have two triangles and we know that the length of this side is equal to the length of this side on this triangle, the length of this side is equal to the length of this side, and this angle is equal in measure to this angle, then without finding anything else about the remaining side or the remaining 2 angles, we can say these are definitely congruent. They're definitely identical. But it's very important to note for this one though as well that it has to be in this order, side, angle, side, or the angle has to be the included angle. So for instance, if I had a triangle, 2 triangles here we'll say, and I knew that this side was equal to this side, and this side was equal to this side, and I knew that this angle was equal to this angle, I couldn't say for sure that these 2 triangles were congruent. Mathematically, they need not necessarily be congruent. They could be different in some of their measurements. So it has to be the angle which is in between the 2 sides. So it would have to be this angle that we knew was the same in both triangles in order to be able to say for certain that they were congruent triangles. Okay. The next one then is if 2 triangles are congruent if 2 angles and the side between them are equal in measure in each. So we call that ASA, angle, side, angle. So again, we have it here. If we know that this angle in this triangle is equal to this angle in this triangle, this angle is equal to this angle, and that side is equal to that side, then we can say that they are definitely congruent without measuring the other 2 sides or the other angle. And again, it is important, the order. You couldn't have this angle, and this side. It has to be the side which is in between these 2 angles. Side that's in between the 2 angles. Okay, and our last one then is 2 triangles are congruent if both contain a right angle and the hypotenuse on one other side in both triangles are equal. So if you're presented, I suppose the shorthand then is RHS for right angle, hypotenuse, other side, basically, and any other side. So if you're presented with 2 triangles, both of which you're told have right angles in them, both of which their hypotenuse are equal in length, and you know that one of the other 2 sides is equal in length to one of the other 2 sides, so in this case I just picked this side equal to this side, then you can say for certain that these 2 triangles are congruent. You don't have to do any more proving. You know that this angle must be equal to this angle, this side must be equal to this side, that angle must be equal to that angle. Okay. So an example of a kind of a straightforward question for now, and we'll do more difficult questions over the next few days. But for now, are these 2 triangles congruent, and if so, why? So we're given 2 triangles, triangle DEF and triangle XYZ. Okay, we're told a little bit about them. We're told that they both have 40-degree angles in them. Okay, we're told that this side, DF, is the same length as this side, XZ, in this triangle. And we're told that the side DE in this triangle is equal in length to the side ZY or YZ in this triangle. Now, you can see that I've deliberately laid them out slightly differently. They're not like this, you know, sitting on the same base with the same side at the top and the same length side at the side. So sometimes you can't rely on, I suppose, your eyes to be able to tell if two triangles are identical or if they're congruent. So what you need to do is rely on your rules. So you can see that you have two sides and the angle in between the two sides, that 40-degree angle, that are the same measure as two sides and the angle in between the two sides in this triangle. So we can say that they definitely are congruent. So this is how we might give our answer. The triangles are congruent, and in maths language we would say DEF. Oh, I've left out the triangle symbol. Triangle DEF is congruent, that's the three lines, to triangle XYZ because two sides in the included angle are equal in each triangle. And how we say two sides in the included angle is side, angle, side, or SAS for shorthand. That's all you would have to say to prove that they were congruent.